Assalamu alaikum warahmatullah. So today in the last video we discussed up to Mendeleev's periodic table. Now and some parts of this Mendeleev's periodic table is left out. So today let's start this topic again. So before that you know that before Mendeleev two more scientists were involved in the purpose of classifying elements or to arrange all the elements known at that time, and they are Duvernier and Newlands. But due to the limitations of their laws, that is by using their law all the elements could not be classified, and that's why the laws were we can say in one hand that rejected or not accepted wholly. The next scientist who forwarded his law, who came forward to classify the elements, is nothing but the Mendeleev, right? We discussed in the last video regarding this. Now you see in Mendeleev's periodic table, you know that the main credit of periodic table goes to Mendeleev, because his arrangement or how he arranged all the elements, it matches with the modern periodic table too, though his concept of arranging the elements were different than that of the modern periodic table, but still most of the cases his arrangement was matching with modern periodic table. Okay, so let's see how he arranged it. So while arranging the elements, as usual, the Newlands and the Duvernier they used the concept of atomic mass. The Mendeleev's too used this concept or this factor of atomic mass, but along with this he considered one more factor, which is physical and chemical properties of the elements. That is, not only the atomic mass is the factor while classifying the classifying the elements, but their physical and chemical properties also played a significant role in the Mendeleev's periodic table. Now in his time 63 elements were known. You know that till date 118 elements are known, but these all elements were not discovered at a time. It was discovered gradually. So in Mendeleev's time 63 elements were known. Now while arranging these 63 elements, he considered two factors. Already I have told that atomic mass and physical and chemical properties of elements. Now regarding the chemical properties of elements, he considered the formation of hydride and oxide. In his table you will see here you see formation of oxide and hydride, that is reaction with oxygen and hydrogen. So in case of chemical properties, he considered how the elements react with oxygen and how it reacts with hydrogen. Now the question may be why he considered oxygen and hydrogen, not the other element, because oxygen and hydrogen are very reactive element, and they actually react with most of the elements. That's why he considered the reaction with oxygen and hydrogen. So now when he was arranging these 63 elements, how he arranged it, he had written the name of the elements and their properties in 63 cards. Okay, after writing the names and properties in 63 cards, he pasted it on a wall on the basis of their properties. That is, those elements are showing the same properties. They have been categorized in the same group. Again, those who are showing the different properties, they have been categorized or they are placed in the different group. Suppose you see hydrogen, lithium, sodium, potassium. These elements are showing similar properties, so they are placed in the same group. Here you see again beryllium, magnesium, calcium. This way he arranged all the elements, that is, those elements are showing same properties, they are being placed in the group, and those who are not, in the second group. This way he arranged. Now group, do you know what is group? Group is here in his Mendeleev's periodic table. In his table, these vertical columns are known as groups. Suppose you see this is a group, vertical group, this is also group, third, 4, 5, 6, these are what? Group. Now these horizontal rows are known as what? Period. This is the row, right? This is another row, this is another row, this is known as period. That is, he arranged the elements in groups and periods. So groups are the vertical columns in his table and periods are the horizontal rows. So after arranging it, he saw that how he arranged it on the basis of their chemical properties, especially how they form oxide and hydride. After that, he got the result while his arrangement was done. Then he saw that these elements are arranged, or they were found that a trend of increasing atomic mass is seen. How he arranged it? He arranged on the basis of their properties. But after the arrangement was completed, or when arrangement is done, at that time it is seen that they are arranged in the increasing order of their atomic masses. Then he forwarded his law, that what is his law? The properties of elements are the periodic functions of their atomic masses. So this is the way how he arranged it. His arrangement is done, and in his table you can see that at the first that is in the first row, you see here how oxide is formed, how hydride is formed. For this particular table, it is shown here. In each and every case, it has been mentioned that how they form oxide and hydride. Now let us come to the achievement of this periodic table. What he achieved it, and what is the achievement, what is the advantage of this particular Mendeleev's periodic table. Now the advantage is that all the elements, that is all the elements having similar properties, are placed in the same group. For this purpose, sometime he placed an element having higher atomic mass before the element having lower atomic mass. In so many cases you will see, suppose here you see, if we consider this is an example, 118.69, now see increasing, 121 increasing, 127.0 increasing, right? But after that you see here 126.90. Actually if the concept of increasing atomic mass is applicable, then this 126.90, that is iodine, must be in place of this tellurium, right? But he did not do it in this manner, because his concept was on the basis of their properties too. So you see fluorine, chlorine, bromine, iodine, you know that they show same property, their properties are same. So iodine is placed here so that the elements in this group can show the similar properties. This is one of the achievement. Now the second one is these elements. Actually in Mendeleev's periodic table, some places were left vacant, that is, it was simply kept empty, because at that time these elements were not discovered. He predicted, at that time he predicted that later on some elements will be discovered which will show the same property as that of this particular column. Now see, for this purpose, this particular elements, scandium, gallium, germanium, actually in Mendeleev's time these places were empty, but he could not arrange it by keeping empty. How he arranged it? He had written in this place as Ika boron, here Ika aluminium, in this case Ika silicon. So because this Ika boron, Ika aluminium and Ika silicon